So this is the procedure which will lead us to the solution to our problem of converting an integer to a string. And you will notice that we will adopt the same procedure or the same approach as we did in the string to integer problem. So if you remember, in the string to integer problem we had two subproblems. The first one was to take a character. After we've divided our string into multiple characters, we had to take, this was one of the subproblems, taking a character and converting it into its numeric or digit equivalent. And what we're going to do now is simply the reverse. We have digits like that, and we want to convert them to their symbol or their character equivalent. And we'll use a similar approach, and we'll see that in a second. This will be our step one. And the step two, of course, once we have all these characters, we need to combine them together to form our string representation of the integer. So this will be step two. So there's step one, determining the character of a numerical digit. Now we're going to use the ASCII character encoding scheme as an example, but most common character encoding schemes also place digits 0 to 9 sequentially, and this will be the property that we're going to exploit. So you see right here, 0, this is the character 0 till 9. They are placed sequentially, and this means that they are character encoding is sequential as well, so they go from 48 to 57. So remember what we did to take a character and convert it to its numeric equivalent. We in fact subtracted 0 from it. So we took 2, subtract 0, and this essentially, this is what it did. The compiler will take 50 minus 48, and it will get you your 2 right here, and this will be a numerical representation of the 2 symbol. So we subtracted 0 from our symbol. Now what we're going to do is, we have this and we want to find that, so what we're going to do is we will add 0 instead of subtracting 0. So we'll take 2 as a digit, subtract the character code equivalent of 0, add the character code equivalent of 0, and you will get from this, you will get your 50 right here, which is the symbol 2. So this is exactly what I'm showing right here. So for example, if we had 8 as a digit plus 0, 0 is, its equivalent is 48. So its character code is 48 right here in this ASCII character scheme. And 48 plus 8 will give you 56. And 56, if you look at it right here, is in fact the 8. Represents 8 internally. So this is in fact the character 8. This is what I'm showing right here. So we will add to every one of our digits the character 0, and we will get its corresponding character. So this was explained in the earlier video. I went over this really quickly, but this explains it. So the next step is to place the characters in their right order. So now that we've found the characters, we need to place them in their right order, and this is the second problem. In fact, it might come before in the actual solution, but these are the two subproblems, and here's how we're going to solve this one. We will look at our integer from right to left, and what we're going to perform is two simple operations. We could have looked at it from left to right, but this actually makes it simpler to look at it from right to left, and I'll explain why in a second. So what I'm going to do is, I have 235, and I want to isolate every single digit of 235. So it's an integer given to me, and I want to isolate each one of them so I could treat it individually, get its character equivalent like we've seen above, and then store it in a string. So what I'm going to do is, I will modulo 235 by 10. So 235 modulo 10 will give me 5. And 235 divided by 10, and this is integer division, so it discards the remainder. This in fact collects the remainder. This is performing the same division right here, but instead of giving you the result, it's giving you the remainder. And here, this integer division discards the remainder, so 235 divided by 10 will be 23. And you notice right here, we actually separated the 5 from the 23. So we got our first digit, and what we're going to do is we'll take that 5, we'll pass it through the algorithm I talked about above to get our 5 character or symbol. And this 5 character, then what we're going to do is we will have a string buffer, and I'm just going to dump it in that string buffer right here, my 5. And I will perform this procedure over and over again so I could isolate each single one of these characters or single one of these digits, get their character equivalents using the procedure above, and then store them in that string buffer. So that 23, I'll take it again, I'll modulo 10, it'll give me the 3. 23 divided by 10, it'll give me the 2. So this 3, I'll get its character equivalent, which is 3, and then I will store it right here. And then 2, I will do the same thing to it until I am left with 0. And then when I'm 2, I'll do the same thing. I'll start it right here, and there we have it. This is 532 in the reverse order. And so that's why in the end I say you're going to have to reverse your string. This will contain your string, but in the reverse direction, you will simply have to reverse it. So 2, 3, 5, and this will be your string that you return from your method. So this is the procedure we're going to follow. We'll look at it more in detail in the algorithm. How are we going to deal with negative numbers? To keep the process simple for us and continue following this, what I'm going to do is I'm going to use a flag. So suppose it was minus 235, minus 235 instead of 235. At the beginning, I will check if this number is negative. So I'll check if it's less than 0. If it is less than 0, I will set a flag so I could remind myself that it is in fact less than 0. I'll set it to true, and then I will just take the positive equivalent of this number, so 235, and I will deal with it according to my process that I just described there. At the end, when I'm done, I will check the flag. If it's true, I will just add a negative character or a dash to my reversed buffer. And then at the end, when I have all this together, like we said, we're going to have to reverse it, and the negative will come at the front of the string. So this works perfectly. So this is our algorithm. The first thing we do is we initialize the buffer. That buffer is right here, right? So it will contain our string. Then if the number, like I said, is less than 0, I will set a flag to true, and I will take its positive equivalent, and I will process it right here. And this is what I'm saying. While the number is not 0, I will go on and do the procedure I described here. So the number modulo 10, to separate it from all the other digits, I want to get only one digit, which is at the far right. And then I will add the character 0 like we described in step 1 to get the character equivalent of that number, or that digit. And then I will take that character right here that I derived from here, and I'm going to add it to the buffer, like I described in this step. And then what I'm going to do is I will take my number, which was supposed 235, divided by 10, integer division, so I could get rid of that 5 because I already processed it, and then I'm left with 23. And I continue doing this until at one point you will reach 2, and you will divide 2 by 10, and this will give you 0, and you will exit the loop because the number is going to be equal to 0. So you will exit the loop, and you will come right here, and you will have a buffer with 532, and then you will check the flag. Is it set? That means it's negative. So you will add that dash, and then in the end you will reverse your buffer and return it as the return of your method.